Hello, and welcome to EcoBlue's official engineering design process video launch. We here at EcoBlue have been commissioned by tech company Green to develop a fully sustainable solar cable car. After a brief discussion with Chairman Elon Gates this morning, our mission is clear: to minimize the negative impacts of tourism on the environment and to maximize tourism's positive impact on ecotourists. Let's meet the team.
Hello everyone, my name is Brett. I'm doing the computer part.
Hey, I'm Isaac, and I'm part of the mechanical team for EcoBlue.
Hello, my name is Jonathan, and I'm a member of EcoBlue's electrical team.
Hello, I'm Mutassim, and I'm a member of EcoBlue's computational team.
Hi, my name is Pratikanchan. I am part of EcoBlue's mechanical team.
My name is Ron Shalvi, and I'm doing electrical stream.
Engineering links science and applications to the needs and demands of humanity, society, and business. As engineers, we are asked to solve particular problems by providing designs that fulfill these objectives and requirements. So, the identification of a clear problem statement is of great significance in order to satisfy the demands and constraints imposed by functionality, regulation, safety, and cost. A sufficient problem statement must communicate what the problem is, who has the problem, and why we must solve it. By making these apparent, the problem statement identifies opportunities for design and innovation, but perhaps more importantly, identifies the constraints and requirements that we must follow, and the area that we are allowed to operate in. Therefore, considerable effort should be made to create a thorough definition of the problem early in the design process, but can be modified along the way, so that time is not wasted on incorrect solutions. The problem definition phase provides a clear pathway that underpins the whole design process. It connects the engineer to the client in a systematic way, in the clarification and fulfillment of objectives, requirements, and constraints that filter undesirable solutions from desirable ones.
After a brief introduction about the importance of problem definition, it is time for me and Brad to talk even deeper, going paragraph by paragraph to justify we have a good problem statement. The modern growth of tourism is a significant contributor to the contemporary climate crisis in its dependence on unclean energy. Tech company Green aims to combat this by setting forth a design proposal for a fully sustainable cable car that catalyzes shift towards renewable energy in tourism. So in the first paragraph, we introduce the background information for our projects. We explain who wants us to do the project, which is the company Green. Also, we stated why might our project be started. This will connect the engineering to the client in systematically agreeing on the objectives. The proposal outlined that the design must rely on two 3-watt solar panels, which must be easily attachable and detachable, and constructed with recycled items of minimal commercial value. The cable car has to be able to mount onto tether without loosening or adjusting the tether. Also, in case of poor weather condition, the car power source must be flexible in that 2 solar panels can be substituted with 1 battery. The whole project is expected to be finished in 10 weeks. So the second paragraph, we introduce the specific details of our project. Here we mention the material we needed for the project and the estimated completion time. We also listed the operation method and special conditions. To have a strong problem statement, according to Rod Morgan said, one of the key elements is to quantify the gap. An example like cost, time, quality, environmental, personal, and etc. These elements would allow engineering to outline a clear path from undesirable situation to a desirable situation.
The cable car must be capable of transporting an ecotourist up a tether which is 10 meters long, 2.5 centimeters wide, and 1.5 millimeters thick, of height 220 centimeters, with a controlled descent to its original starting point to the end of the tree, ensuring the safety of this passenger at all times. An Arduino will be used to limit current flow to vary the speed of the motor in order to control the climbing and return. The cable car must be totally safe for the ecotourist, meaning it shouldn't involve hazards such as exposed screws or sharp edges. The design must be unique and innovative, with aesthetics appealing to the general public. The design must also fit with a cube of side length 400 millimeters during all points of the core, so that is not unnecessarily large. So in the third paragraph, we have the construction of the tether, and we have the risk assessment, and also at the last we talk about the personal experience for the cable car. So I think it's a pretty satisfied problem statement. Thanks.
Naturally, within the engineering design process, the success of the problem statement is the conceptual design phase. Now, you may be wondering what the conceptual design phase actually entails. Well, Icelandic structural engineer Snorri Gudmundsson believes it is a process which formally establishes the initial idea. We at EcoBlue agree. We see the conceptual design phase as the means by which engineers take the first leap to bridging the gap between a great idea and a great product. This phase is the time where the ideas which have been manifesting inside the brains of engineers find their way into drawings and sketches, into a physical means whereby solutions to the world's problems begin to take shape. However, the profound importance of the conceptual design phase truly arises in what scholars have coined as collective intelligence. Research into this notion is best demonstrated in a 2015 paper authored by Jean-Pierre Belot. This paper, titled Collective Intelligence to Solve Creative Problems in Conceptual Design, explicitly states that conceptual design is the most important task in product design, and is the phase that involves the most uncertainty, requires the most creativity and coordination of different agents. And therein lies the importance of the conceptual design phase, as a process which involves integrating the creativity and innovation of multiple unique minds to accumulate a bank of feasible solutions. This collaboration to join intelligence and knowledge to achieve a common objective conveys the sheer necessity of the conceptual design phase, as the period in the engineering design process where the individual wits of our team amalgamate to produce solutions better than any of our individual work. Our team will now discuss our application of the conceptual design phase and how our collaboration manifested into some unique and well thought out designs.
Effective concept generation techniques are crucial when it comes to generating a large number of acceptable solutions. Initially, our team started out with the gallery method, which allows team members to develop ideas independently, but then pulling them together afterwards to develop them further. This allows team members to receive feedback on their ideas from the rest of the group. This was followed by a brainstorming session where the objective was to come up with as many ideas as possible without judgment from the rest of the team. This allowed us to generate a large selection of ideas in a small window of time. We then took these ideas and formed a morphological chart. This involves listing properties and functions of a design solution and then multiple options for achieving each. Then we formed combinations of these to generate concepts. This allowed us to visualize any parts of the cable car that we possibly neglected and then generate more ideas for it. These techniques allowed us to develop the following solutions. This method of attaching to the tether involves two pulley wheels that are above and below the tether that push against it to get a firm grip. Then a motor spins them in opposite directions with the help of gears in order to push the cable car along the tether. This is a concept that we came up with to ensure the cable car can automatically switch directions when it needs to. So the idea is that an ultrasonic sensor that is connected to our Arduino will constantly check for the presence of an obstacle. And if there is one, it will be able to measure the distance between them. If this distance falls below a certain value, let's say 20 centimeters, the Arduino will reverse the direction of the cable car. We can achieve this with the Arduino by using a motor controller to limit the flow of current that goes to the motor. This will reduce the motor's torque and allow us to use the gravitational force to direct the net force of the cable car down the tether. To ensure a safe, controlled descent for the eco-tourists that are inside the cable car, we'll increase the current slightly as the cable car is going down the tether to ensure it's not accelerating during the fall.
Our design incorporates the use of 3 independent LEDs. These LEDs are of different colors, with green indicating that the car is moving up, orange indicating that the car is stationary, and red indicating that the car is now descending. These lights will have an average power rating of 60 megawatts, meaning that they will have negligible effects on our overall supply of 6 watts from the solar panels. The lights will be controlled by an Arduino circuit, which will involve 3 separate current paths, which are all disconnected from each other. The Arduino sensor is connected to the motor circuit and will control the path of current in the LED circuit by measuring the amount of current in the motor circuit. In terms of skeleton of the car, we will attempt to construct it with completely recyclable materials. We are still contemplating the use of cardboard or some sort of timber to ensure structural integrity. Timber offers a more sound structure, but it is usually heavier, which will slow the car down and is more expensive than easily accessible cardboard. For this reason, it appears as if that cardboard might be an easier option for us.
So, where do we go from here? As part of the engineering design process, we will now focus on 4 key steps. Firstly, we will use the criteria of our morph chart to establish a final design. We will then perform tests, experiments, and calculations with circuits, code, and the motorization of our cable car. Once this has been completed, we will look to source our materials, including recyclable ones and the necessary electrical and mechanical hardware. Finally, we will assemble our cable car, which will hopefully resemble our design as you can see here, and safely transport our eco-tourist. From the team here at EcoBlue, thank you for joining us in making our future a cleaner and greener one.